All right, so we're going to finish up our last conic section, which is hyperbolas, and that's 6-4. Start off with the definition. Okay, it says a hyperbola is a collection of points in the plane. So again, this is a flat shape. It's not 3D. Where the difference between two fixed points is a constant. Okay, so it's a collection of all points in the plane. The difference of whose distances from two fixed points is a constant. This is almost identical to an ellipse. If you change one word in that definition, it is the definition of an ellipse. Instead of yesterday, we didn't look at a difference. Anyone remember what we looked at yesterday? It was a sum. Yeah. So in an ellipse, you're looking at the sum from the distance of two fixed points. A hyperbola, you're looking at the difference. Because of that, ellipses and hyperbolas have a lot in common when you solve the problems. They're going to feel very, very similar, except one small change. And we'll have a plus sign. Instead of a plus sign, you're going to have a minus sign. But that'll be it. Any guess what we're going to call these two fixed points? Same name we gave them yesterday?
Foci.
The foci. Okay, the two fixed points are the foci. And let me show you a picture. Okay, so that's a picture of an ellipse. I'm sorry, of a hyperbola. Okay, and what we're going to notice, the hyperbola here, it's not connected. It's in two separate pieces. Okay, all hyperbolas are in two pieces. Right. And as I move point E, notice the distance from E to C and B to E is changing. But if you subtract the difference, it always comes out to 5.66 for this particular hyperbola. Okay, if I go over to the other side, it always comes out the same. So find the two distances, subtract them, you're always going to get 5.66. Okay, any question on that? That's a hyperbola. There's two ways that a hyperbola can look. Kind of like an ellipse, there's two different ways. Hyperbola can either look something like that, or it can look something like that. So the two pieces either line up horizontally or vertically. Okay, the line that goes right through the foci, that's called the transverse axis. Let me go back to our picture. I don't know if I had the foci labeled on here. Let's see. I do. C and B. Okay, C and B are the two foci. Notice it's kind of like a parabola. The hyperbola has to wrap around the focus. That's how it works. Each part wraps around the focus. Okay, so the line that goes right through the two foci, that's your transverse axis. If you were to draw in a segment between the foci and then find the midpoint of it, that's called the center. So if we had something like this, that was a foci, focus, and that was a focus. If you draw in that segment, find the middle of it, that's going to be the center of your hyperbola. Okay, that'll be the center. Okay, the other axis, instead of like major and minor, like we have with an ellipse, the transverse axis goes right through the foci. The conjugate axis goes the other way. So the conjugate axis never touches the hyperbola. It goes right down the middle. That dotted line I just put in, that would be the conjugate axis. It's perpendicular to the transverse axis and goes right through the center. question on the term so far? Foci, transverse axis, conjugate axis, center. So you've noticed that the hyperbola has two parts to it. I haven't called them what they are properly called. They're branches. So you either have a left branch and a right branch, or you have a top branch and a bottom branch. That's what the two pieces are called, the branches of the hyperbola. Okay, and last thing to define are the vertices. Well, if you look at where the transverse axis hits the hyperbola, those are your vertices. There's your branches. Let's say there's your transverse axis. Two vertices are right there. In this picture, your two vertices, actually one of them looks like it has a little kind of X shape on it. That would be a vertex. And the other one, it's not labeled, would be right about there. That would be your other vertex. Okay. Any questions on the branches or vertices? All right, so we'll try to do this like we did before. We'll look at the simple case where the center is at 0, 0. We'll do a couple, and then we'll look at the case where the center is not 0, 0. Okay, but as I said earlier, we're not going to complete the square with hyperbolas. All right, let's look at the equation. If you look quickly at that equation, you might think that it's the one for an ellipse. Okay, it looks very similar. It's got an x squared, y squared. It's equal to 1, just like an ellipse. It's got an a squared and a b squared in the denominator. Anybody recognize the only thing that's different? Well, h and k will come in if we shift left, right, up, or down. So we could have an x minus h and a y minus k, but that'll be the very last thing we do.
Oh, it's subtracted, not added.
Yeah, you've got a minus sign instead of a plus sign. It's the only difference in the formula. Minus sign instead of a plus sign. And the relationship between a, b, and c, it's similar. Okay, yesterday it was c squared equals a squared minus b squared. Today it's c squared equals a squared plus b squared. That's the difference. This is why it's hard to keep all the formulas straight, because they're so similar. All right? So again, I would put them on a review sheet. Let's see. Foci are negative C0, positive C0. Vertices, negative A0, positive A0. We can use the same idea as we had yesterday. A is the distance from the center to the vertex, and C is the distance from the center to the focus. And the last thing with a hyperbola, this is going to help us when we have to make a sketch. It has two asymptotes. Okay. Everybody know what an asymptote is? So an asymptote is a line that something gets closer and closer to, but it never actually touches. Okay, so when we sketch an asymptote, or when we sketch a hyperbola, it's going to have two asymptotes, and I'll show you when we do an example. They're going to look like an X shape. Okay, one might look something like that, and the other one might look something like that. The reason these two dotted lines are going to help us is they're going to tell us exactly where to put the hyperbola. It's going to be right in the kind of that little V part of where the X shape is, right? And same on the other side. Once we draw in those two diagonal lines, it tells us exactly where to put the hyperbola. Now, it could be up and down, or it could be left and right. I'll talk more about that once we've done an example of each type. That's fine. Don't worry about that stuff. Okay, this is important. But if you have your notes from yesterday, you already have that written down. A is the distance from the center to the vertex. C is the distance from the center to the focus. So if you get the notes from an ellipse, it's the same thing. Okay, again, don't worry about the part that's up above it. Okay, any questions on the formula before we try to do a sketch? On the test, I will tell you what shape you're working with. So when you're trying to solve a problem, I will tell you this is going to be a parabola, or this is an ellipse, or this is a hyperbola. So you'll know which of the three you're going to do. And what I'll do is I'll try to group them all together. I'll put all the parabola problems together, all the ellipses, and all the hyperbolas. Okay? All right, so let's try this example. Okay, it says find an equation of the hyperbola and graph it. Does everybody have what's on the left? Good. Bless you. Okay, so just like an ellipse, first thing you want to do is try to find A, B, and C. If you can find those three things, then you fill in the formula, and you're all set. Okay, so my center is 0, 0. My focus is 3, 0. What letter is that going to help me get? If I know where the focus is, it's going to help me to get C. If I know where the center and the focus is, find the distance between them. That's C. What's the distance between the center and the focus?
3.
3. How about the vertex? What letter does that help me get? A. Find the distance between the center and the vertex. How far apart is the center and the vertex? 2 units apart. How are we going to get B? Yep, so C squared equals A squared plus B squared. Just remember that for a hyperbola, now you use plus, not minus. Okay, so C squared is 9. Let's see, A squared is 4. Subtract 4. And we get 5 equals B squared. Okay, do we really need B? The formula doesn't have B in it. The formula has B squared, so you don't really need B. Okay, so let's just leave it as B squared. Those are the two things we need. Okay, so we have x squared over a squared. What's a squared in this case? 4. Minus y squared over b squared. What's b squared? 5. And just like an ellipse, what's it always equal to? 1. There's my equation. Okay. Any question on the equation? Right, now let's graph it. Only 2 things you need to graph a hyperbola. You need to know where the vertex is, and you need to draw those diagonal lines. That's it. Okay, let's start with the vertex. They tell me that I have a vertex at -2, 0. Now, they didn't give me the other vertex, but there has to be another one. Where's the other vertex going to be?
2, 0.
Yeah, it's going to just be on the other side. Remember, there's a symmetry to it. -2, 0, +2, 0. And last thing, let's get those asymptotes. That's going to be the diagonal lines. This is how you get your asymptotes. You don't have to find anything new. You're just going to use A and B again. So there's two of them. Positive B divided by A and negative B divided by A. That's the slope. Okay, it's giving you the slope of the asymptote. Okay, in this case, I guess we are going to use B, so we could write it in square root of 5. So positive B divided by A. That's one of them. And what's the other one? Just put a negative in front. Yep. Do negative B divided by A. Okay, those are the two asymptotes. Okay, let's graph them. Both of these lines, what's the y-intercept on both those asymptotes? Yeah, 0. Think of y equals mx plus b. There's nothing on the end of this. So there's no intercept. They're both going to go right through the origin. So that's 1 point. Okay, and I need one more point. We can use a calculator. Let's let x be 2. Just plug 2 into this first equation. Let's see what we get for y. Okay, you don't have to use 2, but you need another point somewhere. So pick a small value for x. So do 2 times the square root of 5. And divide by 2. Basically cancels out. So when x is 2, y is about 2.2. So 2.2. Do I need any more points to draw our line? No, I just need 2. Okay, so I already had this one drawn, so there's one of them. And let's do the other one. Oops. Let's do 2 for that one. Same thing. So if I type in 2, got square root of 5 times 2. Remember, this time it's a negative, so I'll make it negative. And divide by 2. So when x is 2, y is negative 2.2. Okay. Is that enough points to draw the other line? Yeah. There's your other line. Now, I don't care how you graph those lines. In Algebra 1, that's one way that I teach students to do it. Pick a point for x, plug it in for y. If you've got another way that you like to use to draw lines, that's fine. You can draw those lines any way you know how to do it. But I think that's the quickest way.
What's the point of the asymptotes?
The asymptotes are going to tell us kind of where the hyperbola is going to be. So I can now...
So like how it curves?
Yeah, how it's going to curve. It's going to go through there, and it's going to be right in between those dotted lines. So it's going to look like this. It has to stay between the dotted lines. That's what that tells us. Okay, and that's how you sketch a hyperbola. So sketch your asymptotes and have it go right through the vertex. Okay, that's probably the only sketch that I'll do today. I don't want to focus on sketching a lot. Any question on that? Yeah. All right, let's try another one. This time I don't want to grab it, just discuss it. Okay, is that equal to what it should be if we're going to try to discuss it? Yeah, it's equal to 1. So that's good. We just got to find A, B, and C. Okay, let's go back at our formula. A is under X, B is under Y. And for today, that's how it will always be. A and B don't switch places. Okay, with an ellipse, they did. With a hyperbola, they don't. A always comes first, B always comes second, always. That never changes. What will switch are x and y today. Okay? We'll talk about that in a second. Okay, so this is a squared, and then 4 is b squared. Okay, so what's a? What's Sarah? Yeah, a is 4. Okay, Emily, how about b? B is 2. And c? Does the formula have a plus or a minus in it? Has a plus. Okay, let's find c. Why do I need c? What's that going to help me to write down? Yeah, the foci. I can't do the focus if I don't have c. So we got to find it. So we get 16 plus 4. And c would be the square root of 20. Good. Okay, so square root 20. Okay, any questions on how we got any of that, A, B, or C? Okay, so let's write down our vertices. Okay. Vertices, if you don't remember, let's just go back real quick. Negative A0, positive A0. Okay, so what are my vertices here? Yep, negative 4, 0, 4, 0. Just like an ellipse. Foci, negative C0, positive C0. So square root 20, comma 0, and negative square root 20, comma 0. Okay, there's your foci. What about my center? 0, 0. Unless you've got an x minus h and a y minus k, there's no shift. 0, 0. And now I want to know which way the transverse axis goes. You get two choices, horizontal or vertical. Okay, here's how you can tell with a hyperbola. Look at where the minus is. Okay. The y is negative. I want you to look at the one that's positive this time. It's the x. Whichever one is positive, that's the direction of the transverse axis. Okay? So it's a little different than an ellipse. You can't look where the bigger number is. That's not going to help. You look at which one is positive. If x is positive, transverse axis is horizontal. If y is positive, then the transverse axis would be vertical. Which one is positive there, x or y? X. So x is your horizontal. Okay, so transverse axis is horizontal. And asymptotes. Okay, I don't remember the formula, so I'm just going to go back. It's b over a times x. So we've got b over a. And you know what? We can do it the way Matt had said earlier. Just use the positive or negative. 2 over 4. What does 2/4 reduce to? 1/2. So if you were going to graph that, if you know rise over run and you want to go up 1 and right 2, you can do it that way. Or up 1. Yeah. Depends if it's positive or negative. Okay, but those are your asymptotes. Okay, that's how you do it. Any questions on that one? Graph, just like we did on this one. How to graph a line, you mean? It might be helpful to know how to make the graph of the asymptote, but it is going to be a matching question. So you still kind of have to know where it's going to go, but you're just going to have a multiple choice. Yeah. All right. Okay, let's do some of this one because then I want to move on to the type where the branches are up and down. What are you going to do first here? That's not ready to discuss yet.
Divided by 36.
Yeah, divide everything by 36. Okay, so that's going to leave me x squared. What will I have in the denominator for x? 4 minus y squared. What's going to be in the denominator for y? 9 equals 1. Now it's just like the other problem we did. Anybody tell me what's A? 2. Yep, A is 2. How about B? 3. C? Just do A squared plus B squared. 13. So what's C? Square root of 13. To me, that's the tough part. Once you get A, B, and C, now you just go look up all your formulas. Okay. Instead of going back, does anyone remember? What's the formula for the vertex? Yep, negative A, 0. And what else? Positive A, 0. How about the foci? Okay, negative C, 0. And positive C, 0. What's the center? 0, 0. Hasn't been moved. Transverse axis goes which way? Horizontal or vertical? Yep, look at which one is positive. Is it the x or the y? Whichever one is positive, that's the way it goes. It goes along the x. That's horizontal. And for my asymptotes, is it b over a or a over b? For this one, it's b over a. Yep. So 3 over 2. And that's it. That's everything. Yep.
Wait, so if it's vertical, would the asymptotes be A over B?
Yeah.
Okay.
Yep. So this is the other case of the hyperbola. This is on page 403. It's almost the same formula, except everything just switches a little bit. A is always first, B is always second on the bottom. Notice which one is negative now. Now it's the x. X and y switch places. Centers at the origin. Foci, you're still going to use C. Vertices, you're still going to use A. Now the transverse axis is vertical. And as Sarah said, now your asymptotes, instead of having a slope of b over a, the slope is a over b. Okay, so we'll do the same thing we just did on the last problem. We'll just discuss it. Okay, Zach, what do we have to do before I can discuss this one? I'm going to make it equal to what number?
Equal to 1.
Yep, equal to 1. And how do I do that?
Divide 4 by everything. Divide everything by 4.
Yeah, divide everything by 4. So that's going to give me y squared over 4 minus, now the 4's cancel out here, but if you want to keep a number in the bottom, what could you keep there if you want? 1. Could keep a 1 there. And then 4 divided by 4 is 1. Okay, what's A? 2. What's B? 1. And then C? C squared equals A squared plus B squared. So C is the square root of 5. Okay, and we got our formulas right here. Let's look them up and find everything they want. Vertices, 0 negative A, 0 positive A. Foci, 0 C, 0 negative C. 0, negative root 5. 0, positive root 5. Any questions on the foci? Where's my center? Yep, 0, 0. How about the transverse axis? Is it vertical or horizontal? Yep, how do you know? Exactly, y is positive. Okay. So I know it's a lot of stuff to try to remember, but that's why if you put it all on a review sheet, you don't have to try to remember every single detail. So vertical. Asymptotes. Positive and negative a over b. A is 2, b is 1. What's 2 divided by 1? It's 2. It's positive 2x and negative 2x. And that's it. Okay. Any questions on that one? Any questions? All right. Okay, we'll do, let's do one more like this, and then let's go to the ones where it's actually going to be shifted. Okay, so find an equation for the hyperbola. What do you think the first thing we should think about finding is? Yep, A, B, and C. Anybody see what A is going to be? Yep, distance between the center and the vertex is 2. B, we're going to have to come back and do that. How about C? 3. Did they have to list both foci, or could they have just given you one of them and you'd automatically know the other one? Yeah, they only need to give you one because you got 0C, 0, negative C. Same with the vertices. You know there's one at 0, negative 2, even though they didn't give it. So, plug in. And what do we have to solve for? B. So we get 9 equals 4 plus b squared. Subtract 4. Okay, what's b? Square root of 5. Is the transverse axis vertical or horizontal? Think about how those foci are going to line up. If they line up vertical, transverse axis is vertical. The foci are down 3 and up 3. Down 3, up 3. They're vertical. Okay, so let's go back and look up our formula where it's vertical. This one. Transverse axis vertical. So y squared over a squared. Oops. Minus. If I kept the plus there, what would that have been? When I accidentally wrote plus. It would have been an ellipse. It would have been an ellipse, which is not what we're doing. Okay, so our final answer, what's a squared? 4. What's b squared?
4.
Yeah, we actually got it right there. 5. And that's it. Okay, any question? Andrew, question? No. All right. So this is the table from your book. If you're going to make a reference sheet, these are the formulas you would want. Okay, so when you see the x minus h and y minus k, that's the translation. Left, right, up or down. Okay, these formulas right here, do it the way I gave it to you. C squared equals a squared plus b squared. Okay, for both of them. Asymptotes, the formula looks much more complicated. Again, we're not going to try to explain it. The slope part's the same, but then they have to account for the k and the h, just like we do in the equation. Okay, and vertices, foci, everything else. right? So again, that's page,
407.
yep, 407. So if you need, I won't leave that up, but if you need to copy that all down, it's all 407. Okay, let's see if we can find the equation of this hyperbola. How many letters do we have to find? 5. Nothing, just 5. Just like an ellipse. Okay, you got to find A, B, C, H, and K. What's HK represent? It's the center. So we're already done H and K. So we already have H and K. All right, so we'll just write those down. What's H? H is 1. K? -2. H is the x value of the center. K is the y value. What else can we find? Yeah, we can get A and C. A is the distance from center to vertex. Look at the center and the vertex. They have the same y value. Just look at the difference in the x's. How far apart is the center and the vertex? 2. So A is 2. Okay, what else can we find easily? B or C? Yeah, we can get C. The distance between the center and the focus. Okay. How far apart are the center and the focus? 3 units. Difference between 1 and 4. Okay. Last letter we need is B. C squared equals A squared plus B squared. All right, so C squared is 9. Let's see, A squared is 4. It seems like we've had this come up a lot where we have 9 and 4, so we get 5 equals B squared. So what's B? Good, square root of 5. Great. Any question on that?
So when you're finding the difference, do you use H?
When you're finding the,
Like from the center to the foci, do you use H?
so yeah, from the center to the foci, this time I used H, yeah. Okay, if you want to draw them out, this one's right 1 and down 2. And the other one is right 4 and down 2. So you're just trying to look at how far apart they are horizontally. It could be vertical though. Okay? Depends on the kind of ellipse. So in that case you'd be using K. But one of the two numbers is always going to be the same. Either the K's or the H's. All right. Now from what I just drew, is the transverse axis going to go horizontal or vertical? Yeah, it's going to go horizontal. So we're using that equation. Okay? It's horizontal. It's going to be parallel to the x-axis. It won't be on it because we shifted it. Okay? It's going to be down here. That's going to be your transverse axis. Okay, so let's write it down. X minus h squared divided by a squared. And then fill in everything except which 2 letters do we leave alone? X and Y. Don't fill in for those. Okay, so we're going to have x minus h. Okay, what's a squared? 4. Minus, Adam, what's going to happen when we do y minus k? Yep, it's going to turn into a plus. Plus what? 2. So you're going to subtract -2. It becomes plus 2. And my denominator here, b squared, 5. And that's it. We're done. That's the equation. Right, so on the test, you won't see as many where the center is shifted. I'm going to try to keep a lot of the centers at 0, 0. Maybe just one question on each type where it's shifted. Because those are a little harder. Okay, any questions on that? Okay, so just like last night, do the best you can with it. Most people gave a good effort, and I think if you try it, you'll be okay. You might not master it in one day, but I think with a little review tomorrow, we'll be okay. Right, so on 411, do 13 to 16 all, 17 to 21 odd, and then 31, 37, 41.